Hi everyone and welcome to Edureka. So welcome to this session on our discussion on the UNIX operating system. So in here we'll be first of all discussing on what exactly is a file, what are the directories and subdirectories which is a part of the structure for UNIX, and what are type of files included in UNIX. So in here we'll be discussing on all the file types available in UNIX, what are the pointers that we have to keep in mind while we are naming them, and what are the terms used in a directory. We will be discussing on the type of path names, what exactly we mean by wildcard characters, how we can manage directories. So in here we'll be discussing on how we can create, display and delete files apart from directories. So first of all, if we have to discuss on files, so file is a container for storing content which records a piece of information. And just like we maintain multiple files and documents into our Windows system, right? Or in any operating system, same way here we have the concept for files, right? And anything and everything in Unix is considered as a file, including physical devices, such as if we have USB devices, ROMs, floppy drives, and so on. So these all are considered as a file. And input and output devices are also considered to be files in the Unix system. And just like if we have a unique name and unique inode number for each and every file in other operating system, same kind of scenario is also available in Unix. And files on Unix are always grouped together in directories, same as folders in Windows environment. Just like we have folders, we can create multiple folders and then we can store a category of files in that particular folder, right? And folder can be based on our own use cases, on the file type. That depends upon us in which context we have the folder created. And then as we discussed in Unix, everything is a file. If something is not a file, then it is considered to be process. And all the attributes are kept in a separate location on the disk. For example, we have programs, services, text, images. So these all are stored separately. Next is we have directories and subdirectories. So directory is, again, as we can see here, directory and any directory. For example, we have folder, and then if we have another folder in that main folder, then that is considered to be a subfolder, right? Same way we have directories and subdirectories. And in Unix system, a directory is also a file containing the name of the other files, or it can be the structured directories having subdirectories are again called as a tree. Like we have discussed the concept of hierarchy earlier. And all type of operations are possible for directories such as create, delete, copy, move, link, split, print, and that means whatever activity we can do for files, the same activity we can do on directories as well. And a directory can be a file, but a file cannot be a directory. That is true. And that's why the file contains information, records, and directory contains the subdirectories and its files here. So we can, in a simple layman terms, we can say file contains the entire metadata. That means what is the size, when it was created, its version, records, everything. Whereas the same thing cannot be available for any kind of directories or subdirectories, right? And then if we have to discuss on type of files, then there are multiple file system available in Unix. So first of all, we have regular or ordinary files. Then we have directory file. Then we have device or spatial file. And then in device and spatial file, again, we can have further segregation. First of all, here we can have raw or character device file, block file, named bytes or FIFO, link, and then we have socket. So regular or ordinary files, they simply contain the data and all the executable programs. And when you talk about executable programs, again, like for example, list, password, or when we are going for any setup, shell scripting, we can store these kind of files as a part of executable program files, right? We had discussed in our previous sessions. And data can be anything. There is no specific, or we can say predefined format. And the ordinary files, they contains the data on top of the ASCII. ASCII, as you know, is a global standard, so which makes the entire code readable to humans. And it includes executable program binaries, program data, and many more other information. And regular file is the one that is not a directory, or it is called regular since there is nothing special about it. So there are no special use cases for the files that we store in the ordinary file system. And directories can be organized as a tree, and regular files can be visualized as the leaves in the Unix tree itself. Just like we had different components, a tree has multiple branches and branches will have multiple leaves. The same way here we can see the entire structure in that manner. Then we have directory files. So directories are the files that contains other files and subdirectories. So directories are basically used to organize the data by keeping closely related files all at the same fields. So that suppose if we have a file system for a file for the website, right? So here we can create a directory for it, and then we can store the files for running that website, all those files in a single directory altogether, right? And if we have multiple pages, if we have multiple documents to create, we can create one document and then we can segregate them. For example, we want to segregate them based on the years, then we can add the folder subdirectories for multiple years, and then we can store files inside it. And kernel Anul can write the directory file, no one else. And when a file is added or deleted from the directory, the kernel will make an entry, just like we have discussed on the concept of log maintenance, right? And a directory is a binary file which is used to track and locate other file or directories. And there can be multiple directories containing large number of file names. There is no limit there. And in a single directory, we cannot keep contents, records, or any other information, right? Whereas a directory file can be visualized as a branch, same as of a Unix tree altogether. Then we have device files. So device or spatial files represent the physical devices. For example, we have floppy disks, we have CD-ROMs, we have USB drives, and they appear in the file system just like an ordinary file or a directory itself. And that's why this type of files allow the access to various devices known to the system. Like we have modems, Ethernet adapters, like we have tape disks, hard drives, network interfaces, scanners, printers, terminals, right? So these all, the access to all of these hardware, again, given by the special file types. When a process writes to a special file, data is sent to a physical device associated with it, because the file type will be limited to only that device. That's why it is sent to that device only. And special files are not exactly files, but we can refer them as pointers to the device they are connected to. And this connection is again being set up by the kernel itself. And protection applicable to files are also applicable for the physical devices as well. And then in type of devices or special files on Unix system, there are basically 5 flavors, or we can say 5 variation of special files for each device. We can have a raw or character device file. Now in here, when a character spatial file is used for device input output, data is transferred from one character at a time. And this type of access is called a raw device access and is present in the dev structure itself. Like we had discussed in our previous model, that we had multiple types, right? So in here, we can have a treated stream of input or output, and terminals are classic examples of these kind of files, especially in the format of raw or character device file. And the most important point to remember is that all the read-write operations to them are direct, immediate, and they are not cached. And then we have block device files. So when a block spatial file is used for device input output, data is transferred in large fixed size blocks here that can be used. And this type of access is called block device access. And these files are hardware files, which are mostly present in the same dev format. And again, here we have block file device file, which provides similar access to the same device. And then we have name pipe or FIFO. So pipe is also called as a name pipe or FIFO. FIFO simply refers to first in, first out. That means suppose if we have added 10 files, then the last file which was added, only that file will be remove first, and then the 9th, then the 8th, 7, 6, 5, 4, 3, 2, 1, like in that format, like first in, first out, right? Or suppose say here we have in the same inverse order. For example, we have put the first file first. Again, if we are removing the file here, then if we have had 100 files, the first file to be removed will be the first file that has entered into the stream as a part of FIFO. And pipes, they simply represent one of the most simpler forms of the Unix inter-process communication here. And pipe, the main purpose of pipe is to connect the input output of 2 processes in Unix to a single pipe, right? And one of the process uses it for output, while the other process will be used for giving the input. And then we have links. So it is basically used for referencing some other files or file system along with the path to the reference file. They are either directory or regular file. And then we have sockets. So socket files is basically used to pass information between applications for the communication purposes. And we can create the socket file just by using the socket system call. And a Unix socket called as IPC socket. IPC refers to inter-process communication socket. It is simply a special file that allows for advanced inter-process communication in the same manner as a socket, and all the transitions are done to the local file system. So these are the common character representation for each and every file type available in Unix. We have D for directory, C for character special file, B for block special file, L for symbolic link, P for named pipe, and S for socket. Where if we have to start using it, we can simply use a syntax as file and then followed by a file name, or we can, for all the files, we can use file and asterisk. For example, if we have the root directory here, if we go ahead and use file asterisk, we will be able to get, or we can say correct the information for the current directory in which we are working in. For example, in here, as you can see here we have a file, and again, whatever files are available as a part, the entire piece of information will be returned back to us. Now, these are the rules for naming a file and directory that we have to keep in mind. A file directory has to be named by which it is identified by the system itself, and the length of the file name should be up to 255 characters or bytes, with combinations of any characters or numbers without giving a space or tab. In naming, we know that we cannot go for a space or tab, and the number of characters should be 255. The files and directory names should not contain any special characters, like we have at the rate, exclamation mark, curly braces, we have and symbol, angular brackets. So these are some special characters which cannot be present in the name. And hyphen or underscore, these are symbols that is used to separate words. Like for example, if we have to have a spacing in between, then instead of adding spaces, we can simply go ahead and use hyphen or underscore. For example, if we have my edu file, so instead of using space, what we have done, we have simply replaced the space with hyphen or a simple underscore. Hyphen symbol is better because in underscore we do have to press shift and then we have to enter the underscore, whereas hyphen can be entered without using any kind of shift symbol or shift key. And dot, or we can say period symbol, is used to separate a file type extension, and it is optional. For example, we have edu.txt, right? Whenever there is a dot, it simply specifies the whatever follows after the dot, it simply specifies the extension of that file, what kind of file it is. And file name should be provided with as a consistent pattern related to the dot file for better understanding. That means suppose if we are maintaining the same hyphen or same underscore for the spaces, if we are maintaining the file, the purpose first and then the file name, then the same common structure should be followed for each and every file available in Unix, so that when a team is looking at those files, they can find some consistencies and pattern in the naming of files as well. And file names can be uppercase as well as lowercase. However, they are case sensitive when we are using them in our program. And a file or directory name should not be a command name. For example, if we can use man command to check whether a given file name is a Unix command or not, like we had discussed earlier. And we should start the file name with a letter, a number. If we start a file name with a dot, it will be a hidden file, because suppose if we have htaccess files, so we start them with .htaccess itself. So if we start a file with dot, then obviously it will be treated like a hidden file. It will be automatically treated like a hidden file in Unix operating system. And file name must be unique inside the directory. Files can have same names, but again, they should be in different locations, because at the end, these files are going to generate paths, and paths have to be different. Just like in Windows, we can have the same file name in multiple folders, right? But in the same folder, as soon as we define the file name, there will be a simple numbering allotted to them, like 1, 2, 3. Because again, we cannot have the same file in the same directory. They need to be in different directories altogether. And file directories should be arranged hierarchically as per the requirement, like a tree structure. And these are the common terms used in a directory. We have root, home, current, or we have parent or previous directories. These are the common commands used in, or we could say these are common terms used in a directory in Unix. So first of all, root directory is a, we can say, the origin directory, just like we have C for the entire Windows, correct? So this will be termed as a root directory. For example, if we open up our Windows system, if you open up a Windows as C, again, this will be considered as a root directory for the command prompt that we work on a local machine, correct? And currently we are for the root user, and again, currently we are in the root directory of our server as well. Currently we are also on the root directory of the server. And that's why root directory is now in Unix and Unix-like operating systems, that is Linux. The root directory is the first topmost directory in the hierarchy, and there is no directory that is above the root directory. And we can have many directories under the root directory. For example, let's suppose if we want to change to a subdirectory here, we can simply choose a command as cd for changing directory. And if we want to come back to home, right? we can simply use cd, and now we are taken to the home directory available inside the root directory itself. And in the reference starting point of all the files, directories and sub-directories are mentioned. When we are referring to the root directory, we simply refer them as a / symbol. And then we have home directory. So home directory is a base or we can say login directory provided to the user. And the name of a home directory is usually same as user's login name. For example, here, if you wish to, now currently we are working on Ubuntu, right? So here we can switch to, suppose if we want to come back to the root directory here, if we wish to switch to the root, we can say home directory. For Ubuntu, we can use cd home, right? And then on the home, we have Ubuntu. So again, this is the Ubuntu distribution that we are working on. And again, this is a home directory that we have available in Unix operating system. And then they can have multiple subdirectories inside it, step by step. And mostly this is represented by a # symbol. And then we have the current or present directory. So again, this simply represents the directory that we are working on. Suppose if we are working on multiple other directories, right? Then we can specify that. And for the first time logins, currently working directory will be a home directory. Like we have discussed, whenever we log in for the first time on servers, we are taken to this working directory itself that is for Ubuntu. And again, here in Ubuntu, we can have multiple subdirectories as well. We can do that. And the command pwd is used for displaying the current directory path that we are working on. If you use a pwd, then again, it will simply display the current path. As you can see, if we just simply type in as pwd, then we are given the home directory in which we are working on, that is home, and the Ubuntu. That means the current directory that is running. And that's why basically it is simply represented by a simple dot symbol. And the parent and previous directory is the one level higher. For example, in here we are working on Ubuntu. So for Ubuntu, the parent directory will be home. And if we create multiple subdirectories in Ubuntu, then Ubuntu will be the parent directory for those child directories itself, right? And again, the parent directory, again, the previous directory is simply represented by a simple 2 dots. For example, let's suppose if we open up our command prompt, if you open up our command prompt here, and again, if in here, if we use cd, and now if you want to return to the previous directory, we have to use a simple 2 dot, right? What it did, it simply returned our, currently we are in the users, and then we have the username. And if you want to return back to our previous directory, then what we have cd, and now we have returned back to the previous user altogether. The same concept is also applied to the Unix environment as well. So if we talk about type of path names, then here, first of all, we have absolute and full path. So now this is a path name that starts with a root directory and is called as absolute or full path. For example, in Windows, when we talk about C drive, and then we have C _, if we have something in Windows, and the Windows, we have something in system32 folder. And again, in system32 folder, we have something in etc folder, and so on, right? So in here, the entire path starts from the root directory, that is C path, right? Same way here we have the type of path names which starts with a simple / rmdir. So using this remove directory, we can simply remove all the directories and subdirectories that we have currently created. For example, same way if you want to remove any of the existing directories. For example, let's say we want to remove web. So we can use rmdir and now the name. And now if we use ls, we won't be able to see the new directory that we did create because we have removed that. We have removed the directory completely. So in terms of managing directories, first of all, we have the command as ls. ls is simply used for listing files and directories that we had discussed earlier. When we use ls in any given folder, it will list out all the available files and directories in that particular folder. And just like every other syntax, it is also accompanied by multiple options that we can use for our custom view. So for example, if we use lst, then it will simply display the last edited or modified files and directories with the ascending order. For example, if we come back, so if we use ls, be able to see the entire list of all the files. If we simply accompany with this with t, then this will display the list of all the files and folders that may have been created or edited in the past. Suppose if we want to list out the files, we want to list out all the files here, then we can simply accompany this with ls-a. And in here we can see now, we have discussed that whenever we write any files with dot, right? When we simply make those files invisible, or we can say hidden by default, right? We have bash history, we have .bash rc, we have GUnpy, we have .shs, bash logout, we have cache, profiles, sudo as admin successful. So these all are hidden files. But when we use LSIA, then this will simply display the list of all the files, whether they are hidden or whether they are visible. Then in here, we simply list all the files by sorting in the version wise. I will simply make sure that we are displaying the inode index number of each file. You will simply make sure that we are listing the file in the order of access the last time. For example, if we use ls and we simply use -u, again, suppose if we have multiple folders that we had created, for example, suppose we create another directory by the name of web here, right? And now suppose if we use ls-u, then as you can see here, now it has been sorted. The last one that we did create was web, and earlier to that we had Edureka. So same way, it will simply list all the files in the same sorting order in which they have been created. And if we use asterisk, this will display all the files and directories. L will simply list one file per line. Suppose say if you're using ls and -l, again we'll make sure that all the files are being sorted one at a time. As a list here, we can see there are total 8 files here, which includes the hidden files. And currently we have the entire root folder. And what is the size? Again, when they were created, along with their name that is being listed as a part of complete list view. Same like we have list view in Windows, same way here we have list view in Unix as well. And then we have -a, where we do not want to list to be implied. And again, if you want to print size of each file, then we can use S. For example, same way here, we can go for LSS. And now this is simply printing the size of each and every component here. And then using P, we can list the files directories by putting /. Using N, we can display the file UID, the unique ID. And then using H, we can print the sizes in human readable format. For example, 1 KB, 2 or MB or GB. And then we have F. F is basically used for classification of files with special characters, if they are special characters. And then we can use L for simply listing the files and directories in the long format with 7 attributes, as in the character, type of file access, number of links, file size, group of files, owner, last modification, and the name of the file. So now for creating the files, we can use a simple command called as touch. So if the file already exists, it will override the file with a new timestamp. And if the file already exists, it will create a new empty file with 0 KB in file size. And we cannot insert any content. Now, touch is only used for creating the file. We cannot insert any content by using touch. For inserting the content, we use a simple editor that we are going to discuss later on in our further modules. And the main advantage of touch is by using a single command, we can create multiple files at once. We can do that. So for example, let's suppose if we want to create the files here, we can go ahead and move to our terminal. Now in here, we can use a command such as touch. Now suppose if we are creating a file for edureka.html, we can specify that. If we want to create a simple file for txt, we can use touch. And in here, we can define web.txt. So whatever the file name is, whatever the extension is, it can be created by using touch. And suppose same way, if you want to create a file, right, then we can specify the properties here as 1, 2, 3, 4, and the files here with the given attributes will be created one by one. Now after that, we have something as cat. So cat, the difference between cat and touch is, if the file already exists, touch will create a new file, a new blank file with 0 KB in size. Whereas cat, if the file already exists, it will not create a new file with the same name under the same directory. It will not do that. And if the file does not exist, it will definitely create a new file in write mode where we can insert any content, unlike touch. And Control+D keyword is used to come out of the file after placing the content. And the main disadvantage of cat command is cat allows a single file to be created at a time. That's why they both have different use cases. Using touch, we can create multiple files at once, and using cat, we can create only one file. Right? Because again, using cat, we are also getting the advantage of adding content directly that is not available in touch command. So again, the syntax remains same. So here we have to simply specify use cat, and then we have to use a less than symbol and then the file name. Right? For example, let's say if we want to create a file name by the name of index.html. So as you can see, currently we have entered, but with the name of index.html has been created, and now we have entered that file. So now suppose if we want to start adding content, we can add HTML, we can add head, we can add suppose title, we can add a simple title such as welcome, we can close the title as well. Then we can open a body, In body, we can place something in center. In center, we can use H1, and with H1, we want to use welcome to Edureka. We can close H1. We can close center. We can close body, which we have misspelled earlier, and then here we can close HTML. So just as a simple example, now once we are done saving it, we can simply press Ctrl D. As you can see, we have simply come out of the entire given job here. So that's the main difference between touch and cat. And then we have another tool with us, which is called as file creation. We have V. So again, if the file already exists, it will open in the edit mode. If the file does not exist, it will create a new file in write edit mode where we can insert, modify any content. And then the keyword escape colon WQ is basically used for coming out of the file after placing the content. And just like we have now, the main advantage of V editor or V command is it allows us to create a single, or we can also create multiple files at a time using a single command line with read and write edit mode. And same, the content remains same. For example, we want to open up the V editor, we can specify the V and then we can specify the file name. For example, let's say we want to create page1.html. So for example, let's say we create a page1.html. Now, as you can see, currently V editor has been opened up, right? So now again, if you want to add any content here, we can easily do that as a part of the content that we are trying to create here, right? And now if you want to make any changes here, we can simply do that. For example, suppose here we want to add any content here. Let's say same way for HTML, we want to add head, we want to add title. For example, let's say we want to add simple welcome. Once we are done, we can close title. Once we are done with our head section, we can close head as well. Then we can open up body. Under body, we can place everything in center. And then in here, we can use H1. In H1, we can simply write welcome to Edureka V editor. So here we can close H1. Then we can close center. Then we can close body. And then we can close HTML. So just like we have seen earlier, so now in here, the main advantages of using this editor, we can come back, we can make any of the changes here. We can easily do that, which was not available in all of our previous editors. And if you want to come out, we can simply press escape. We can simply write colon and WQ to simply come out of the current editor here. And now for seeing the content of the files as well, we can simply go ahead and use the same editor. So for seeing the files or for viewing the files that we have been working on, we can again use the same editor. Like we have CAD, VI, we have OD, view, more or less. These are the common syntaxes we can use for viewing the content that we have currently created. For example, suppose if we want to view the same content that we have worked on, right? We can use the same command. And as you can see, now we can see the same content that we did create a couple of minutes back. So again, if you want to come out, we can simply use W key, escape, and colon W key to simply come out. Same way we can go for any other editor that we have been working on. And now for seeing the file content here, we can use another command such as more. So more is basically used for viewing the long files. And then when we keep on heading spacebar, for example, we have a long file here, right? That needs to be scrolled down. Then using the spacebar, the screen here will be shifted accordingly so that we can view each and every component of the file. You can say in multiple sequence, we can do that. And once we are done, we can simply press Q to get the entire overview for the entire code that we are referring here. For example, let's suppose if we want to see for any file here, we can use more and then we can specify the file name. For example, here we have more page1.html. As you can see, the entire file is being now visible to us. Now, since this is a short file, that's why we are not given any option for changing the view as well. Had it been a long file, then we could have simply shifted our position by using a simple spacebar. Right, so here we can simply view the entire content without going into the content page altogether, or we can say without going into the content editor altogether. And same way, if we have a large file, if you want to see the less content, we can simply specify less, and then again we can also specify the file name. Then if in order to delete the files here, we have the option as RM. RM simply refers to remove files, right? So if you want to remove the file here, we can simply specify RM command and then followed by the option name. So for example, here we can use the RM syntax and then followed by a simple option, and then we can specify the file name. For example, in option, we can use -I, which basically used for interactive deletion. If we can use R or uppercase R, which is basically used for recursively deletes deletion and the entire content and directories of the subdirectory as well. The entire directory and subdirectory will also be removed. and then we can use F. F is basically used whenever the current file is being used by any program. So normally if a current file is being used by any program, then we cannot delete it, right? Still, if you want to delete it, we can simply use the syntax as -F, and this will simply forcefully delete it. Thank you.